Do you ever wonder how it is to live like a red blood cell? Well, look no further. We'll join our joyous reddish friend, RB.
Welcome, new blood cells. I wish you all the best on your ventures throughout the human body.
Among the billions of blood cells produced by the bone marrow daily, a little red reticulocyte emerged, curious to know the processes involving RBC. This reticulocyte was called RB. In the bloodstream, the little reticulocyte matured into a full-fledged erythrocyte capable of carrying oxygen. RB has finally grown and became an official red blood cell.
Hello everyone! My name is RB, the friendly red blood cell. Join me in my long and adventurous journey to the blood vessels.
RB is ready for his first mission, picking up oxygen. His first stop is the lungs. This is where he picks up a fresh supply of oxygen. Inside the lungs are tiny air sacs called alveoli, and this is where gas exchange happens. How does the oxygen get to the blood, you may ask? Well, it all comes down to diffusion. Diffusion is when molecules move from an area where they are more concentrated to an area where it is less concentrated. So inside the lungs, the alveoli are packed with oxygen from the air that we breathe. But the blood in the nearby capillaries has very little oxygen since the body has already used it up. So since the oxygen naturally moves to where there's less, it diffuses from the alveoli into the bloodstream. Once in the blood, the oxygen gets picked up by the special protein inside the red blood cell, which is the hemoglobin. RB arrives at the lungs and sees oxygen bouncing inside alveolus.
Let me out! It's too packed in here. I got you!
That's hemo for you. He sticks to the oxygen in the lungs. Let's go when we reach the muscles. Hold on tight!
While RB is carrying oxygen, the body also needs another important fuel, the glucose. But where does RB get it? Inside the small intestine, tiny finger-like structures called villi absorb the glucose from food and pass it into the blood. From there, glucose hitches a ride in the plasma, which is the liquid part of the blood, until it reaches the muscles, where it will be used up for energy. Unlike other cells, red blood cells can't use oxygen for energy because they don't have mitochondria. Instead, RB absorbs glucose from the plasma and breaks it down without oxygen using a process called anaerobic glycolysis.
Alright, where is my next delivery?
The food has been digested and we're sending glucose into the blood. Get ready!
Finally! We're now small enough to leave the small intestine.
Come on in, Lukey. The blood is waiting for you.
Phew, carrying oxygen is tiring. I need a little energy too.
Hey RB, there's a lot of us in the plasma now, but not enough inside you. So, we're about to diffuse into you.
That's better. Since I don't have a mitochondria, I'll use anaerobic glycolysis to turn this glucose into ATP. Alright, glucose secured. Now I just have to deliver it to the muscles and organs that need energy. Time to keep moving!
RB has been traveling through the bloodstream, carrying oxygen from the lungs and glucose from the small intestine. Now, he's arriving at the body's hard-working muscle cells, which needs both of these to produce energy. But it's not just a simple drop-off. RB must interact with the organelles inside the muscle cell to ensure everything works properly.
We're running out of fuel. No oxygen, no glucose. How am I supposed to make ATP now?
If we don't get energy soon, the muscles won't be able to move.
RB releases oxygen and glucose, which passively diffuse from the bloodstream into the muscle cell. Since the concentration of oxygen and glucose is higher in the blood and lower in the cell, they naturally move across the capillary walls into the muscle.
Finally, oxygen oxygen and glucose. Let's make some ATP.
Thank goodness. Now we have enough ATP to power the muscle.
RB successfully delivered oxygen and glucose to the muscle cells, where Mighty Mito used them for cellular respiration. But after all the work, something else is left behind. Waste. Carbon dioxide has built up in the muscle cells and needs to be removed. RB must now pick up carbon dioxide and carry it away before things get messy.
Does anyone need a ride? I've got room for waste.
Arby, you're a lifesaver. Please take me with you. I don't belong here anymore.
RB has successfully picked up carbon dioxide from the muscle cells, preventing waste from building up. The journey isn't over yet. Let's follow RB as he makes his way to the lungs for the final step.
Arby, good to see you again. Ready for another gas exchange?
You know it. Sadie, time for you to get off.
Back in the lungs, carbon dioxide is exhaled through diffusion from the high concentration in the blood to the low concentration in the alveolus.
Alright! Mission accomplished. Sadie is out and I can now reload with oxygen and continue my fulfilling journey.
And that marks the first cycle of RB's work routine, which he will do over and over again in his lifespan of 120 days. RB will continue to be a devoted hard worker that ensures effective oxygen delivery. While RB works diligently, billions of new blood cells are being generated in the bone marrow. This new batch of RBCs will then follow the footsteps of the legendary RB.